Hello everyone, my name is Paula Sanchez Saez, and today I will tell you about the AGN variability studies that we are doing in the context of the ALeRCE project. So ALeRCE is an alert broker, and that means it's a system that processes alert streams coming from large time domain surveys like the Zwicky Transient Factory or the Vera Rubin Legacy Survey of Space and Time, or LSST. So an alert is produced when a change in the sky is detected in a science image that is not present in a template image. So when we subtract these two images, we obtain a difference image with a detection. It can be a positive or negative detection. So currently, currently ALeRCE is processing the CTF alert stream in order to be ready once Vera Rubin starts operations. And ALeRCE currently have two classifiers models. The first one is the stamp classifier that uses a convolutional neural network to classify the first stamps detected for a given object using the science image, the template, and the difference image. And we use this classifier to classify sources as AGN, supernovae, variable stars, asteroids, and bows. So this model has been optimized for the selection of supernovae in very early stages of the supernova. So the ALeRCE broker also has a second classifier called the ALeRCE Likert classifier. And in this case, we have a model that uses a random forest to classify all the sources with 6 or more alerts in a given band. So in this case, we use the whole Likert to classify sources as different classes of transients, different classes of stochastic sources, and different classes of periodic sources. And in particular, we have three classes of active galaxies. We have jet-dominated or blazars, core-dominated or quasars, and host-dominated or AGNs. And when we compare the results of these two classifiers, we can see that they have a very good agreement, even though they were trained completely independently. So what are the studies that we are aiming to perform in ALeRCE related with AGNs? Well, one of the first goals of ALeRCE is to detect intermediate mass black holes and low mass AGNs. And to do that, we are focusing on low mass galaxies. Why? Because low mass galaxies are expected to host intermediate mass black holes or low mass AGNs. So in the past, previous studies have tried to search for these kind of sources using other data sets, but these data sets have been limited by the sky coverage and by the time span covered by the survey. So in this case, we will use CTF and in the future LSST to classify intermediate mass black holes and low mass AGNs using the very well sampled Likerts that CTF provide and LSST will provide in the future. So the idea is to include intermediate mass black holes as a class in the Likert classifier. And currently, we have some preliminary results using the current version of the Likert classifier, and we have found some interesting sources that, when we see the SDSS spectra, are classified as star forming, but in the Likerts you can see a lot of variability. So we believe that these galaxies host an intermediate mass black hole or a low mass AGN. And when you see the colors of these candidates, you can see that they're very red. And we are also aiming to detect changing-look AGNs in real time. So changing-look AGNs are sources that change their classification as type 2 to type 1 or vice versa. So the idea is to detect these sources as the transition is happening, so in real time. And why we want to do that is because this early detection of changing-look AGNs can help us to understand in a better way the physical mechanisms behind AGN variability. So to do that, we are going to provide forecasting services so we can predict the behavior that a given source will show in a given amount of time. And whenever we see a difference between this forecasting and the observed Likert, we will trigger an alert. And if the alert is consistent with a change-in-look event, we will trigger follow-ups. So in summary, ALeRCE is an alert broker system that aims to become an official LSST broker. And currently we have a ALeRCE classifier that allows us to classify different classes of AGNs. And we are aiming to perform a machine learning algorithm that can help us to detect intermediate mass platforms and low mass AGNs at different redshifts. And we are also aiming to perform a forecasting technique that can allow us to select in real time changing-look AGNs. Thanks for your time and for watching this talk.